Ileli. I'm in Mumbuni Boys. I'm an examiner in mathematics, paper 1. So today we're going to share about what the examiner, what the council expects a candidate to work out in the maths questions or the maths paper. I'll start off by working out on what is expected of you as a candidate, on what gives you marks, and how to score those given marks. I'm starting off with the type of marks we have in mathematics. The type of marks we have. So we've got around 7 type of marks. There is M, which is normally the method mark. And then we've got A, which is normally the accuracy mark. And then we've got some other mark which combines the method and the answer, or the accuracy, which is a B mark. We've got, when it goes to the graphs, we've got S, which is for scale. Then we've got P, which is for plotting. Then we've got C. After you plot, you need to draw a graph, the curve. So after P, we've got C. We've got C, which is for the curve. And then we've got, you might be also drawing a line. So we've got L, which is for the line. So those are the type of marks which are expected, or rather which the examination council gives out. But then there is the way to score these marks. Out of all those given 7 marks, the bulky of the marks is actually the method marks. And the method marks is the mathematical concept. That is, depending on the question given by the examiner, if you work out the right method, the right mathematical procedure, then you are awarded the marks. KCPE and KCSE mathematics might be marked very differently. In KCPE, what was expected was only the answer. But in KCSE, you can miss the answers, but still score marks. That is even part of the instructions, that marks can be awarded even when the answer is wrong. And is also qualified by the statement that you should show all the steps in your working in the calculations. Like, for example, I want us to see how we can work out one question about fractions. Like you are told, without using a calculator, evaluate 2 1/3 minus 1 1/5 of 2, all these were near divided by a quarter minus negative a half cubed. Negative a half. Negative a half.
Without using a calculator.
Negative a half cubed. So in this question, what the examiner expects you to do is you use the first principles, the basic rules of working out fractions, which is actually following BODMAS. So you will be able to award marks if you follow that BODMAS. So for example, in the numerator, we can start off with the numerator. So in the numerator, you're going to have You work out the 2/3, you make it improper fraction, which is going to be 7/3 minus 6 out of 5 multiplied by 2, which ends up giving you 7/3 minus 12/5. So when you work out this one here, you're going to get it as -1/15 when you work it out using the LCM as 15. That is the numerator. Then you can work on the denominator. And the denominator, you follow again BODMAS, whereby you work out with what is in the brackets. So this one here simplifies first to 1/4 minus -1/8 because of -1/2 cubed, which ends up giving us 3/8. 3/8. Then finally, you work out -1/5 divided by 3/8, which is going to be the same as 8/3, which ends up giving us, oh, this is -1/15, so which ends up giving us -8/45. So the idea here was to evaluate without using calculators. So the first mark would be when the numerator is put under one denominator. So at the process slightly before -1/15, you score a method mark. And for the denominator, slightly when you put it under one denominator, that is over 8, a step just before the 3/8, you are going to score a method mark. And then, of course, at the answer, you get A1. That is what is expected of you. That you work out the method following BODMAS, you will score marks. And then finally, at the accuracy. We could have another example, show how those given marks come about. It's a question about solving simultaneous equation using the matrix method. So you are told use matrix method to solve 5x plus 3y is the same as 35, and 3x minus 4y is the same as -8. Using the matrix, first you write it in matrix form. So 5, 3, 3, -4. All these one here multiplied by xy as a matrix is supposed to give us 35, -8 as a matrix. That's what you're going to have. Then the next thing is you get the inverse of the pre-multiplier matrix, which is going to be first, you need to get the determinant of that matrix, which is going to be the same as 5 times -4, all these one here minus 3 times 3, which ends up giving you -29. So for this, the method to get the determinant, you score a method mark. Just that multiplication, those given values. And then the next step is to pre-multiply both sides with the inverse. So finally, what you're going to have is you are going to have the xy being equal to -1/20. That is the reciprocal of the determinant into, you interchange those given values, -4, -3, -3, +5. All these one here multiplied by 35 and then -8. That expression gives us that we've got xy on the other side because we have already multiplied by the pre-multiplier. That is the inverse of that matrix. And finally, what you are going to get out of this one here is that xy is going to be the same as 4 and 5 as a matrix, but then you need to extract this so that you get x as 4 and y as 5. That's what you're going to have. So you had already scored a method mark for the expression of the determinant. Then the expression to get the values of x and y at this level here, you will get a method mark. That is what the examiner will award you. And then you will work out finally. And when you extract those, the two values for X and Y, you score a method mark, L1, because those are the correct methods. But then there is a condition about the accuracy mark with relation to the method mark, whereby, for example, in this one here, we are working out for the inverse. A student might be tempted to work it out as this, that he has -1/29, and then he has 35, -8, multiplied by -4, -3, -3, 5. And then miraculously he ends up getting this 4, 5. So he talks about X is 4 and Y is 5. The answers are correct. But this step here for the second mark, the step for the correct mathematical expression for getting XY is wrong because of the order of the matrix. So even if the answer is correct, that will be a method mark because that is not correct mathematics. And finally, since we've got that, then you'll also score the answer as 0 or the accuracy as 0. So the method mark and the accuracy are tied. So for you to be able to score those given marks, then it means you must work out from the correct methods, the correct mathematical method. Otherwise, if you get a 0, you will not score the accuracy. So as we prepare ourselves for the exam, let us concentrate on getting the correct methods, not at getting the answers, because the answers without being backed by the correct method, they will not give you any mark. Then we can check on maybe these other marks involving the graphs, whereby you told that you are told to draw the graph of y is equal to 4 minus a quarter x squared for the domain -4 less or equal to x less or equal to 4. In other words, for the domain -4 up to 4 inclusive. And this one here, you are given, that is, for working out that, you are given 4 marks. Just an example, you are given 4 marks to work out that. So in the first place, for this one here, you need to first generate a table for the working out. And then after that, you've been given a grid. Then you are supposed now to plot that on the grid and draw that graph. So it will work as, first, what you need to do is generate a table for these values, whereby you are going to have X and Y from the given domain given. So we start from -4, -3, -2, -1, 0, 1, 2, 2, 3, and 4. So you work out these values. Sometimes the examiner can break them down, but also give you the value of y. So for example, in this one here, we are going to have the values when x is -4, that's the value for y. When x is -3, this is the value for y. This is going to be 3. This is going to be 3.75. This is going to be 4. This is going to be 3.75. This is going to be 3. Then this is 1.75. And then this one here is 0. That is what you've got. So that is now generating the table. And for those given values of the tables, since you are only, the examiner wants to see whether you've got the correct values for y, matched up the pairs, the -4 with 0, the -3 with 1.75 and all that, then he'll give you a B1 for all the correct values of in that given table, both matched. for those given values, because here is giving out that because he's combining it, the method and the accuracy. Then the next thing you go to is now to work out, on now plotting that. What the examiner does, he'll give you a grid that is drawn in that. So what comes next is that you must work out a scale which is going to accommodate all your values, and be able to fit the whole graph. For you to score this mark in scale, and this applies to all graphs, one, when you have been given the scale, when given the scale by the examiner, you must follow it. When given the scale by the examiner, it's a must that you follow it. Whatever it tells you to do on the x-axis and the y-axis, you must follow it. But then, when not given, when the scale is not given, then you choose two things. One, you should have your scale should be accommodative. Accommodative means that, for example, the x-axis should be able to accommodate from our graph, should be able to accommodate -4 up to +4. And then on the y-axis, it should be able to accommodate from the least is 0 and the highest is 4. So you should be able to have that. That's what accommodativeness means. Then the other thing is that scale should be even. That scale should be even. Even is this. For example, if we have been given, if this is the x and this is the y, and then you work out with, you say that 1 centimeter on the x-axis is 2 units. 1 centimeter is 2 units. Then it should be seen, or rather you should be able to plot it in that way, that the 1 centimeter is to 2 units on both ends, even on the negative end. -4, -6. Then on the vertical axis again, then you could say maybe the scale given is 1 centimeter is to 5 units. So this should be 5, then this should be 10, then this should be 15, and below that, then we should have -5, -10 for 1 centimeter to represent 5 units. That's what it means by being even. And then it is the values. Like in this case here, if I work with this, although it's a little bit stretched, it's going to accommodate all the values I have in my graph. But if you work out such that it is not like now, for example, if I could change this one here, if I could change, maybe I have this on the x, then this one here, I have it as -1. I have it as -1. And then maybe this other one here, I have it as -2. If I have that in that given form, then it means that the scale is not what? It's not even. That's what it means. So the scale should be accommodative. And even doesn't mean that the scale should be the same on the x and the y axis. So that is about the scale for you to be able to score. So for what we've got here in our graph, then we need to have all those. Then the next thing we need to have is the plotting. P for plotting. Plotting. P for plotting. And for plotting, you need to work out those given values. Like now, for example, in our graph here, we are supposed to have -4 being plotted against 0. Then -3 being plotted against 1.75. So if I could have it sketched out here, I can use 1, 2, 3, 4. -1, -2, -3, -4. That is working out with 1 centimeter to 1 unit. And I could also work out the same for the vertical axis. Could have the same for the y-axis. So that is 1, 2, 3, 4. No, this is 4. Then we could have -1. That is why. So plotting now, this one here would be 0, -4, 0. You plot that given point there. -3, 1.75, some place here. Then -2, we have it as 3. -1 is -3.75. Then 0 is 4. And then it goes back again. 1, 2 is 3. Then 3 is positive 1.75. And then 4 is that. So you'll be able to score for the plotting if you have plotted all the points correct. And it's all the points, not 2 correct or 3. It is all the points correct. Then you'll score the mark for the plotting, which is normally 1 mark. Then the next thing is now you are supposed to draw a curve. So you are supposed to join these given points now with free hand. Free hand. So that is your curve, whereby now you'll be able to score for the curve. And this one here, normally the examiner in curves, he usually gives out this CCO, correct curve only, whereby this one here means that the table was correct, the plotting of the points was correct, plus the curve is drawn with a free hand and it is smooth. That is how to score for the curve. And then you'll have gotten all the given 4 marks for plotting that. 1 for the table, then 1 for the scale, 1 for the plotting, and 1 for the curve. The only thing you need to master in this one here is that at any given time, the curve, that is the marks will always depend with the table. Because if you miss the table, you don't get all the correct points, you'll get a B0. You lose that mark. So when you lose that mark, then it means whatever you are plotting is not what the examiner wanted. So that gives you what? A P0. When you join it with a curve, then again, it means that the curve you are drawing is what? Is also wrong. So you will not score for the curve. And then normally when you are plotting a graph, then we are going to have other questions related to the graph. That using your graph solve this. So again, whatever you'll be solving from this one here, then will also be what? Will also be wrong. So it means that when you are dealing with graphs, the most crucial part is about getting the table correct. Otherwise, the table will determine all those other given values to work out that. And then when we've got all these given graphs, then sometimes we also have a line to be drawn, for the given curve, for the given graph rather, whereby maybe you are told to use it to solve an equation, which happens in quadratic and cubic graphs. So when you are going to draw a line, we know that a line basically needs only 2 points for it to be drawn. But you are encouraged that you add another point just for confirmation. You've got 3 points. 2 points are enough to draw a line, but then we need a third point just for confirmation. And then a line must always be drawn with what? Must always be drawn with a ruler. Always. A curve should be drawn with free hand and is supposed to be smooth. Then, especially when it comes to transformations, that is when you are dealing with isometries, that is rotation, reflection, enlargement, and all that. One thing we should master about the scale is that for the scale, in transformations, the scale so for transformations, which comes up in two topics in secondary school mathematics, that is in Form 2 and then in Form 4, whereby it's combined with matrices. For transformations, one thing we should master is that the examiner will be very much concerned about your scale, whereby the scale on the X and the Y axis must be the same. The scale on the X and the Y axis. So the scale on the X and the Y axis must be the same. Why do we have it being the same? We have it being the same because if we are going to draw a rectangle on the X, on the Y, or that is on the Cartesian plane, and then the units are not the same, then if the units on the X and the Y are not equal, then a rectangle might look like a square. A triangle might look like a different figure. So that's why in transformations, the scale must be the same. This is scale. Scale must be the same. Then the other thing about transformations, when you are dealing with this one here, for the plotting, you are expected to plot the given point, plot the point, and then immediately label it. Otherwise, a diagram without points being labeled, then it's not a diagram. Like now, for example, just giving out an example here on the Cartesian plane, Y and X, I draw my object as that. That is my object. Then I reflect it maybe on the Y-axis, and I get it out here. They might be the correct ones, but if you check my diagrams here, they are not labeled. You have plotted, yes, but they are not labeled. So we should have maybe this was A, this is B, and this is C. That was the object. So the image will be now A prime. This will be C prime. If it's reflection, then this will be B prime. So they must be labeled correctly. So you plot the point and then you label it correctly. And again, just because when you're dealing with plain figures, you're also dealing with lines, then you should also draw using what? Using a ruler. That is what matters so much in the given graphs. So for you to be able to score those points, then you will need to work out that way. So what generally the examiner will expect from you is that a given question, you should approach it with the given content, with the given mathematical content given. What is expected from that given question as far as maybe the topic and the approach from the information which is given by the examiner. Otherwise, accordingly, you will score the marks for that. Otherwise, if you approach it differently, then you are not going to be able to score the marks. One other thing about the Kenya National Examination Council is that it will also give you, provided you have approached, you can approach a question in very many ways. There are different ways of working out that. They'll be able to follow up and follow all those given methods and award the marks correctly, provided it is mathematical. If the concept is mathematical, they'll always have those given options. There is a word the Examination Council uses that follow through. Follow through means you follow what the student is doing, and if it is approved that is correct mathematical procedure, then you award the marks as expected. Then, our scoring marks in any given exam is what we all want to get. But then, we also need to know how to lose those given marks we have been able to score. There are the penalties for the given or for the examiners, for mathematics. Whereby, for example, we talk about using 4 significant figures. We talk about using 4 significant figures that maybe you have been given a question by the examiner and you are told that work out, evaluate whatever you are given. So what the examiner expects you to do is you work out with numbers, you work out with all the figures to the minimum figures you are supposed to operate with. Minimum is supposed to be 4 significant figures. You work with 4 significant figures at all times. But then you can work with more. but you need to work with the minimum of 4 significant figures. But of course, also follow up the instructions given by the examiner, because sometimes he might also tell you that give the answer to these given figures, to 1 decimal place or to 4 or to 2 significant figures. But all through, you are limited to working with a minimum of 4 significant figures. If that doesn't happen, then if you use fewer figures, then the examiner books you for something referred to as PA, and he deducts you 1 mark. PA is premature approximation. Premature approximation. That we have used less figures. So the examiner will mark all that, you will follow all those through, and then at the end of it, deduct you 1 mark for what you have, for using less figures in that. Then there is another one, which is also very punitive for working out, which is MR, which is misread. This is supposed to be misread, and you lose 2 marks. This is misread. Misread is when you have been given some figures, but then you don't work them out the way they are given. Like, for example, you are given this 0.164 multiplied by 81. You are supposed to evaluate that. It's just an arbitrary example, 0.164 multiplied by 81. But then when you are writing this one here, because of the tension maybe during the exam, then you write this one here as 0.146 times 81, which is very possible. That you have misread, you have misplaced the 4 and the 6, you have interchanged them. When you work out this one here by multiplication, it doesn't mean that you don't know mathematics, because we'll work out this one here and get a value. But that value is not the original answer to the question which was given by the examiner. So in this case here, what you have misread is the figures, which doesn't make the working easier. So what happens is that the examiner will follow you through with your new value now. Will follow you through with that new value here, and there'll be a new answer for that. So he'll mark and see whether you have done the correct thing, award you the marks, but then at the end of it, deduct you 2 marks. 2 marks. If, for example, that question was 2 marks, then you will get 0. If it was 3 marks, you will get how many marks? 1. You will get 1. But there's no need of having that, losing 2 marks just for simple thing about misread. But misread has got some, it has got some rider. The misread allowed, misread minus 2 is only allowed for figures. For figures, but it's not allowed for words or signs. Like, for example, if we have been told to write 140, but then in this case here, you write it as 130. Huh? What we have misread is the 40, and 40 is a word. So this one here is not going to be allowed. So this one is not going to be treated as a misread. It is not going to be a misread. And the same case, if you have been given, let's say 156 plus 140, 1481. 156 minus 1481. Then maybe a candidate feels that this number, I cannot remember we are working out this number using the number line. So you go ahead and feel like you are going to have 1481 minus what? 156, because that one looks easier, isn't it? So what happens here? What have you done? You have misread a sign. Huh? So in this case here, that is not also going to be allowed. The misread will not be there. Yeah? We are not going to have that. So you cannot misread words, and you cannot misread what? Signs. So what you need to do is you need to be very keen on given values that you don't misread them, because it is a little bit expensive when working out with that. On the PA, maybe something I jumped. On the PA, because of the premature approximation, one, then it means we are supposed to use 4 significant figures. And that's why when we are joining from 1, you are told to come with 4 significant figure tables, actually from NEC. So that's why it insists on that. So for PA, again, if we are going to use pi, there are 3 pi's which we can use. There is the famous one, 22/7. Then there is the pi as 3.142. So you should use 3.142 significant figures. And then the other one should be the calculator pi. You are allowed to use those. Otherwise, if you use 3.14 any figures now, if you know 22 over that, like for example, 3.142, you use it at 3.14, then that is a premature approximation, and you are going to lose 1 mark at the end of it. Then there is another one referred to as OW. OW is omission of work. This is omission of work. Omission. Omission of work. Nowadays, it might not be very much practical because of the calculators, but what might not have been affected by the calculators is the factor sign. Like for example, if you have got the factor, you have been given this one here as A, B, that is a triangle whereby that is factor A, and then this is factor B, and then you are told to express BC in terms of A factor A and factor B. We know that BC should be the same as BA plus AC. And when we work out this, then BA is going to be negative what? Factor B plus A, which can also be worked out as minus B. So we have got the factor signs. But then if I work out this one here, such that I don't have this, and they are factors. So this one here isn't there. I have it as that. And even maybe on the diagram, I've not indicated anywhere. Even these ones here up there, they are not there. When there is no factor sign anywhere in a question whereby you are dealing with factors, then you are deducted 1 mark. OW minus 1. You lose a mark for lack of factor method. So when again you are working out, make sure that you have the factor sign indicated. So those are the major errors or penalties which we're going to be administered to you if you work out things not the right way in math. But then I encourage students that avoid those penalties, because marks already scored, when they are being subtracted again, that brings a lot of problems, and that is reducing a score which we had already worked out from the mathematical concept. But to avoid this, some of these things, like for example, the working out of the misread, that is when somebody gets the misread wrong, you misread figures, depends with the way you are situated in the exam room. We know that not so many of us like exams. We don't like exams. That is normal. So when you don't like exam, it's not abnormal. But of course, we know the way nature is, that is, exams have to be done. Yes. So to be able to. So we must find a way of working out this. And to avoid that, then the only thing is you must be settled in the exam room. And to be settled in the exam room, you need to follow some procedures. Like now, for example, if we are going to work out a question, you realize that the examiner gives you some marks. Like for example, it can be number 1, and then you are told that this one here is of how many marks? 3 marks. In fact, he gives marks for all the questions. He gives you that. But then if you total that, if you total all these, then you realize that at the end of it, you are supposed to go how many marks? 100 marks. for the whole exam, isn't it? Section 1, 50, section 2, 50. You are supposed to score these marks in for how long? 2.5 hours. Huh? 2.5 hours is how many minutes? 150 minutes. Huh? 120 plus 30. That is 150 minutes. Huh? So you are supposed to score 100 marks in 150 minutes. So if you work out this one here, then you realize that 1 mark, you are supposed to score it in how long? 1.5. 1.5 minutes. 1 minute and 30 seconds. Huh? So 1.5 minutes. So it means in this question where there are 4 marks, how long should you take? How long should you take? Simple maths. 4.5. So 1 mark you are supposed to score in 1.5 minutes. So 3 marks, multiply 3 by 1.5. So of 4.5 what? Minutes. Huh? That's what you are supposed to score those marks in. So you limit yourself. If it is 10 marks, like the questions in section 2, if it is 10 marks, then you are supposed to take how many minutes? 15 minutes. That way, you will not be able to panic, because the problem when we have this is when you are still in section 1 and the invigilator is telling you that you are left with only half an hour. You panic. So the examiner gives you the marks here so that they can guide you. That as you work them out, you know how much you are supposed to. It doesn't mean that you always keep on looking at the work clock, which is always available in the exam room. Doesn't mean that. But you can always time yourself that in this number 1, which was 3 marks, I think I've taken 3 minutes or I've taken 6 minutes. So it means I've eaten time for some other part. But that also doesn't mean that you panic. That you realize that in a question in section 2, you have taken 20 minutes, which we are supposed to have taken how many minutes? 15. You don't need to panic. It's only that you have taken some time for another question. But that means instead of scoring 100, you are going to score 95. Huh? That's what it means. Huh? Because when you work with 1.5, it means you are supposed to score at the end of it 100 marks. So when you have taken more time, it only means that you have reduced the marks, which is still good enough. 95 is good enough. What am I driving at? I'm driving at this, that you should not panic now that you have spent a lot of time in one question. But then you should be guided by this. So when you don't panic, then you'll not be able to make these given errors you've got here. Then another way of also avoiding these given errors is working out with moving from answering these questions from known to what? I would not like to call them unknown to the ones which are a bit challenging, more challenging. Because when you have finished the syllabus, will there be anything unknown? When you are through with the syllabus, will there be anything unknown? No, it's only that we are going to have something more what? Challenging. So, NEC prepares the maths papers very well. Both paper 1 and paper 2, they prepare them so well that there is space after every given question for working out. So you don't need to follow the procedure. You start with number 1, you go to number 2, you go to number 3 in that order. No, because there is space for every given question. You start with the one you are most comfortable in. Yes. The one you can remember that maybe the ideas and the facts are just as your fingertips. So you start with that. Even if it's number 24, start with it. Work it out, and then move from the ones you know to the ones which are more challenging. That way you will not waste time and you will not do what? You will not panic. And one good thing with mathematics is that the moment you answer a question and then you feel this one here you know and you had the facts, and then you answer another one, then you also feel that this one here you had the facts and you have already gotten it. By the time you reach the third one, then you realize that you have got so much confidence in the exam that you even realize that everything here is possible, isn't it? Yeah. Even the one you are feeling that was more challenging because of that, working out from the known, then you realize that, oh, I was only missing this given point here. And then you'll be able to work them out. And that way, you will avoid those given mistakes and will be able to score more marks in that. The rules in mathematics are that section 1 is compulsory. That is, you answer, compulsory means this. Section 1, you answer all the questions. You answer all the questions. And in section 2, you answer only five questions. Each one in section 2 is worth 10 marks, but the others in section 1 are, of course, the marks are, they are different, but ranging between 2 and 4 marks, normally between 2 and 4 marks. Sometimes candidates make a mistake. You get into the exam room and you want to double up. You want to be a candidate, and at the same time, you want to be the examiner. You work out some work and then you feel, you mark it and you feel this is not what? It's not correct. It is not abnormal to behave like that. It is okay. So if you can still want to double up, there's no problem. But when you double up, it means that whatever you had worked, like now, for example, this was number 3. So you had some working out there, then you divided your work. Then you work out on this end here. You work out, and then you realize that it is not correct. So you start working out in this other one here. You start working out a second way. When you have worked out, you can even work out both ways, and then you realize that they are not correct. You even go for another method. You feel you are not very sure. So some candidates like canceling this. You cancel that work. You feel this other one is not also correct. You also cancel. When you have already worked and you cancel, when you cancel any work in an examination, you don't create any space. Do you? You don't create any space. You only need to squeeze it some other part. But the most interesting thing in maths, you might realize that this work you have cancelled might have been the correct thing. Huh? It happens in mathematics that the work you have cancelled might be the correct thing. Examination Council instructs all examiners that when you are marking, mark all the candidates' work. Mark all the candidates' work. That is a condition. All the candidates' work. So the examiner is supposed to check through that paper, everywhere in that given paper, and then he marks all what you have written there, which is mathematical. Even sometimes when you don't have space, you can even direct the examiner and tell him, this number, move to this page. He will still go to that given page there. He'll mark. Then out of that marking out, if it is a specific number, you have done more than one method. So he'll check all those work, all that work you have done, and then mark them accordingly. And then award the marks, give out the marks in the given working, which has got more marks. Are you getting that? That you had done one step, one method, and maybe out of 3 marks you have scored 2. In the other method, you have scored 1. Then you had another third one, whereby you scored the 3 marks. So he'll pick the 3 marks and give you that. If it is the 2 where he had 2 and 1, then he'll give you the 2. But there is one thing, apart from that instruction that you should mark all the work, then in mathematics, you don't mark cancelled work. Don't mark cancelled work. It is never marked cancelled work. So if you feel that this working is not correct, when you cancel, in fact, you lose. So because the examiner will not cancel. But then if you leave it and then work out another method, then the examiner will mark everything. And then award you. So what you need to do is don't cancel any work in mathematics. Don't cancel any work in mathematics. Because canceling won't assist you. It will not add you space for working out, and the examiner will not mark that. But then if you leave it uncancelled, then the examiner will mark and then give the marks, where it is give out what you have scored more. So don't cancel that. But then in section 2, you are supposed to answer only 5 questions. But sometimes it can happen that a candidate answers more than 5 questions. So if you answer more than 5 questions, then you need to direct the examiner on what he is supposed to mark. You need to direct the examiner on what he is supposed to mark. Like now, for example, there is section 2, there is number 17, there is 18, there is 19, there is 20, there is 21, there is 22, there is 23, and then there is what? 24. Those are 8, but then you're only supposed to mark these ones here, 5. So a candidate does more than 5. If you do 5, that is well and good. But then if you do more than 5, like now, for example, you did number 17, you got 8. You did number 18, you got 10. You did number 19, you got 9. You did number 20, number 20 you didn't do. You do number 21, you score 10. And then you do number 22, you score 2. Those are 5. And then you go ahead and do number 3 and you score 10. Huh? Those are already 6. Huh? You have not guided the examiner. You have not guided the examiner on the given numbers. Guiding means either you tell the examiner to mark this or you tell the examiner not to mark this number. Like now, for example, if I had worked out this one here and then I feel, if I check from my working, of course the marks are not there, but from my working, I realize that number 22, I'm not very confident. So I'll cancel number 22 on the working out there. I cancel it completely. I say, or even right on top there, don't mark. So the examiner will ignore that and pick number 17, 18, 19, 21, and number 23. But then if you don't direct the examiner on what he's going to mark, he's going to pick the first 5. And he believes that you started from number 17, which might not have been the practical case. You might have even started with number 23. So he'll pick number 17, number 18, number 19, number 21, and number 22. And total those marks, whereby these ones here are giving us what? 39. Huh? They are giving us 39. But if you directed the examiner then and told him not to mark number 22 by canceling the number 22 or simply writing don't mark this question, then you'd have picked number 23. So in section 2, that's the only place we are going to cancel. And only canceling, you cancel the given question which you feel the examiner should not do what? Should not mark. But don't make a mistake some students do, that they know a question must be cancelled. You do 5 questions and you feel one question you are not very sure, you cancel it. Huh? Are you getting that point? That you have done only 5 questions and then you cancel one, you say don't mark this. You only cancel when you have done more than what? 5 questions. And cancelling has got there are 2 ways. That is a page like now, for example, number 22. That is the number 22 you have worked out here. You can cancel it by drawing a line across, or you can just say don't do what? Don't mark. You can involve the examiner that way. Don't mark. But this is only when you have already done more than 5. Otherwise, I'll encourage candidates that you don't cancel any work in mathematics unless it is in section 2 and it was an extra what? Question. It was the 6th question or the 7th or that. Otherwise, if you cancel, it's not going to be marked, and that way you will lose some given marks you are supposed to get. Then when the examiner works out, that is, goes through your paper, and then he might realize that some of the answers were not coming from correct. They were not coming from genuine working out. That way, if they are not from genuine working, in other words, the working is not correct, but the answers are correct. That is a very bad signal you are sending to the examiner. The signal you are sending is that you have cheated in this given exam. And we know the consequences of cheating. So what I encourage you is that if you don't have that concept, then the best thing to do is just leave that question. Huh? Leave that question. Because if you work it and then you work it the wrong way, to imply or rather to create the picture that you got some assistance from maybe another candidate or from whatever, that the answers are correct, but the working is not okay, then the examiner will penalize you, and penalizing you, you know that you are going to get a Y, which is an irregularity, and you are not going to get results. And according to the NEC policy, then you'll have to stay for 2 years out before you do another exam, before you are booked again by NEC to take an exam. So we stick to this, that the method marks are the most important. They are the most important in getting the best grade you can ever have in maths. So let us stick to the methodology and the given procedures, the mathematical procedures of working out this, instead of creating a picture that you have the answers, but then you don't have the method. That is what is going to work out for you. And we know that we cannot always, all of us, work out, be the same. We cannot always be the same. In maths, we will not talk about a normal curve. We need to be redistributed in the normal curve. But we always would like to do the best in mathematics. Doing the best in mathematics, there are always, I know your teachers have told you, there are always those given topics which are very popular with the examiner. But there is one concept about the examiner, especially on the graphs method. On the graphs. There are so many graphs in mathematics, and the examiner will always test you on graphs. And graphs are very simple to work out because you only need to generate the table to get the B mark. Again, you will work about the scale. When given, you have to follow it. Then you will go to the plotting, and then you will go to the curve or the what? The line, and then apply this given information you've got to answer the question which follow. Those are 10 marks which somebody can score very easily. And there is variety of graphs in the secondary school mathematics. So one point you can be strong in, when we talked about working out from known to the more challenging questions, then you can build confidence in graphs, because graphs are easy. Graphs and other topics. Graphs is just an example. Graphs and other topics, whereby you specialize in them so much, because the examiner will always test you. It always takes very many marks in mathematics for both paper 1 and paper 2, such that you work out on the graphs and be able to specialize in them, whereby you are assured that at least you will score some good marks in that. And since we have got so many graphs, then we talk of, you can organize on what we refer to as the 7-day graph rule. The 7-day graph rule, whereby you work out graphs from Monday up to Sunday. From Monday up to Sunday. And working out this one here, I can guide you. We know we've got so many of them, and I've said that we encourage this because most of the graphs, they are easy marks to score, and they are going, because there are a variety of them. The examiner will always test you having so many marks. So for example, you can have now your rule 7, that on Monday, you can work out on quadratic graphs. Quadratic graphs. At least you solve 1 or 2. But at least you solve a graph, a quadratic graph on Monday. Quadratic graphs are very much connected to cubic graphs. So on Tuesday, you go again and work out a cubic graph. A cubic graph again will be able to combine both the quadratic basics or principles and the cubic principle. They are very related. Then On Wednesday, you can go to trigonometric curves. Trigonometric curves. Famously referred to as the trigonometric curves. Again, you do 1, 2, or even if you've got time, you can do more. But at least you work out that graph. Then on Thursday, you can work out statistical graphs. In statistical graphs, we've got a variety of them. Starting from Form 2, whereby we've got the histogram, frequency polygon, and then you move to Form 4, where you will have the ogive, where you determine the median, the quartiles, and all that. So statistical graphs on Thursday. Then on Friday, you can go to the matrices. Matrix stroke the transformation graphs. You can work on that, the matrix and the transformation graphs. Then on Saturday, you can move to the linear inequality graph. Linear inequality graphs, which stretches from Form 2 to Form 4, whereby in Form 4 we have the linear programming. And then on Sunday, you can move to the straight line graphs. Straight line graphs. Straight line graphs. Especially these ones here come up in Form 3, whereby we've got determining law, and whereby we come up with a line of what? Line of best fit. Best fit. Line of best fit. So that way you'll be able to master the graphs, and we have talked about at least doing one graph or that. And again, that is part of it. Graphs are part of it. Other subjects which are also very popular with, not other subjects, other topics which are also very popular with the examiner, apart from graphs, which can make you also be able to score very well. Apart from graphs now, we've got trigonometry, which we know trigonometry comes up in, there is trigonometry in Form 2, there's trigonometry in Form 3, there's trigonometry in Form 4. So trigonometry is also another topic whereby you can work out building confidence, that is working from the known to that. Then you could also go to constructions, which are also simple ones to work on. They are not very challenging. Then quadratics are topics you can build confidence in. Quadratics, statistics, and angles. These are simple topics with the examiner. They are popular with the examiner, and they are easy to master and be able to score very well. Otherwise, that might be mainly what the examiner might really be interested in. I might have not captured what you really expected so much, but that is generally what the examiner expects from you, or rather how the examiner will be able to score you in the exam and be able to get some good marks from the working out. So the next phase now I could have is maybe some interactions with you and more so about some questions. So I'm ready to take some questions from you. Yes? Just come up again. Yeah. Okay, that is a good question. It comes up, like, for example, I think I could answer that question with an example here. That whereby some given parts of the question are tied in the second one. They are tied in the second one. Like, for example, you could be given this one here. This is a past paper question. I've got that given one there, and I'm told that the first question is I'm supposed to find the area of triangle ABC. I'm supposed to get the area of triangle ABC. I'd been given this as 3.4, and this one here as 7.2. And if you take triangle ABC is a right angled triangle. So for me to be able to get this one here, I need to get AB, the height of that. I use Pythagoras theorem and get AB, which is actually supposed to be 6.347. That's what is going to be AB. And then getting the area now, the area will be the same as a half times 3.4 times this height here, which is 6.347, which is going to give me 10.79 to 4 significant figures. That is what I'm supposed to get. And then the next part, I'm told to find, just write aside here, part B, I'm now being told to find the size of angle. Find size of angle BCD. BCD. I'm supposed to get the size of that angle. And then now I use the sine formula, whereby I would use, because I have got, it is BCD. There was an indication here that the area of triangle ABC is equal to the area of triangle BCD. That was a condition given by the examiner, that the area of those two triangles are equal. So now I work out and have this one here. That one was given as 7.5. So I work out and say that that is the angle ABCD. Since the areas are the same, then I work out here as a half times 3.4 times 7.5. Sine of what? Sine of angle C is going to be equal to 10.79, because the areas are the same. So I'm using 10.79 in the next one. So let's say that, for example, here, I did not get this answer correct. Maybe I got it as 10.64. So it means if I use it here, I'm not going to get the correct size of C. So for me to be able to score this, it will depend with what I've gotten. Like, the expression for the area, was it the correct expression from the AB? Yes, it was correct. So M1. So then I missed the answer. I did not get it. But I only missed the answer because of some calculation. But the method is correct. This area, if I had gotten it correctly here, it will be okay. So I love this one here, where I have the expression I have of 3.4 times 7.5 sine C is the same as the value I got here, which is 10.64. I'll score the method mark, but I'll not score the accuracy mark. I'll not score the answer. But if this method here was wrong, it means the mathematical concept I'm using there is not related to the area of a triangle. So even when I use it in the other part there, it's not also area of a triangle. So if the method mark was not scored, then I'll miss all the answers. but then you can collect the method marks. That is the method marks as you move down, if you are going to relate some work you have done up there and then down there. I hope I have answered you. Still, I'm taking questions. Yes, yes. In mathematics, you are allowed. So she's asking whether you can score marks when you write the formulas in.
Nani ako na swali? Kuna mmoja ako na swali? Nani?
Yes.
Was? Oh. Ndaka mtu kumbe na swali?
You hang. You have started an expression and then you hang. Yeah. Yeah. So what happens? The examiner will check. That is the question about you start some working out and then you get stuck. Some points such that you don't finish that given number or you don't finish the question. So what happens? There are always marks, the examination or the examiner will award marks according to given stages. When you get at this given stage, you award this mark. When you get to this given stage, you award this mark. So the examiner will only award marks according to the work you have done. If you have done some work and before you got stuck, you had already scored a mark, that mark will be given. But if you edit, then of course you cannot give out marks where there is no working. Because when you hang or when you get stuck, you cannot continue. So you will not get the marks after that. So you'll mark up to where you got stuck and award the marks accordingly. So even getting stuck, don't get discouraged about getting stuck. You can still earn marks, but try to move ahead and move beyond that getting stuck. Excuse me, if we are online, please unmute your microphones if you are going to ask questions. So are we already through with the question? Yes? Yeah. She's asking in longitudes and latitudes, when do we use the cosine theta and when don't we use the cosine theta? In longitudes and latitudes, actually it's very easy for students to be able to master that concept and to apply it. Because that comes up when we are dealing with distance along a great circle and along a small circle. So the first thing you need to know is that distance along a great circle. And when we are talking about cosine of great circle, these are only circles. The great circles are circles which have got the same radius as that of the Earth. That is all the longitudes plus equator. Then we've got the small circle. The small circle. And we've got two ways of working out this. We can either get it in nautical miles or in what? Or in kilometers. Or in kilometers. So in kilometers. So along a great circle in nautical miles, it is simply 60 what? Theta. Whereby theta is the angle difference between the latitude, because we're talking about a great circle and their longitudes. Or if it is the equator, then the theta in this case here will be for the longitude. That is along a great circle. Then in kilometers, again, it will be theta over 360 2 pi r, whereby r is what? The radius of the Earth. Then the small circle, it is the radius of the small circle is given as r cosine of the latitude. That is the radius. The radius of the small circle is given as r cosine of the latitude, and r is the Earth's radius. So since we are comparing the two of them, then the only thing you need to do here now, you just add cosine of the latitude at the end of these formulas. That now when you're looking for the small circle, then it only goes to 60 theta cosine of the latitude. So I wish you could even use the word, instead of using theta, because the theta is already coming up, use the word latitude. 60 theta cosine of the latitude. And even the other one here in kilometers, you also do the same, 300 theta over 360, 2 pi r cos what? The latitude. So you use it when you are getting the distance along a small circle. And the small circle are the latitudes. And in this case here now, the theta is different. The theta in the small circle is the angle between the longitudes, isn't it? Yeah. While the theta in the great circle is the angle between the latitudes. The theta in the small circle is the longitudes, and the theta in the great circle is the latitudes. So that is how you apply that. I hope I've answered you. It's okay. Yes?
Good afternoon.
Cos 300 300 minus sine 240 over everything now here. Over sine into brackets negative 300. This is degrees, huh? Negative 300. What is the instruction? Without using that, huh? Okay. This is very simple. This is a concept in Form 2. This concept in Form 2 is about, if you remember, is about the trigonometric ratios of special, not triangles, angles, special angles, whereby the special angles are 30, 60, and 45. Those are the special angles. So that is what we are being asked here. But then the examiner is combining this concept in Form 2 with the concept in Form 3. Because when you are dealing with that concept in Form 2, is about the acute. In Form 2 is about SOHCAHTOA, right angle triangle, whereby the other angles are acute angles. But then in Form 3, we generalize all this. So we work out with this, whereby for this, we'll bring in about the unit circle. And in the unit circle, we've got these letters. Huh? We've got those letters. Huh? And we know this is 0 degrees, this is 90, this is 180, then this is 270. That is moving and clockwise is positive. Huh? Then when we move clockwise, it is negative. So it is bringing about this one here. So when we talk about cosine of 300, we know that 300 is in the fourth quadrant, where cosine is positive. But which angle are we looking for? The angle adjacent to the horizontal axis, which is actually going to be how many degrees? 60. So cosine of 300 is the same as cosine of 60 degrees. Then minus, then we go to 240. 240 is in the third quadrant, between 180 and 270. And sine in that quadrant is what? Negative. But the angle adjacent to the horizontal is how many degrees? 60 degrees, isn't it? It's 60 degrees. So again, now this one here, since it's in the third quadrant, then this one here is going to be negative sine of what? 60 degrees. Negative sine of 60 degrees, the whole function of the trigonometric ratio, negative sine of 60, not the angle, but negative sine of 60. Then all these one here divided by sine of negative 300. Negative 300, it means we move clockwise. Huh? And negative 300 is going to be in which quadrant? The first quadrant. Huh? You move all that. Huh? So it's going to be in the first quadrant. And that angle in the first quadrant is going to be how many degrees? 60 degrees. Huh? Yes. Because if you move clockwise, at 0, it's 0. Then at 270 is negative 90. At 180 is negative 180. At 90 is negative what? 270. And then at 0 again is going to be negative what? 360. So it means then we are talking about sine of negative 300 as the angle now. We are talking about the angle 60 degrees in the first quadrant. And in the first quadrant, all the trigonometric ratios are positive. So now we are talking about sine of what? Sine of 60 degrees. So all this is 60 degrees. Then now, because we are supposed to use it without, we are supposed to work it out without using the calculators or the mathematical tables, what do we do now? We move to determining these ones here using the triangle. And we work out this one here. For the 60, we use an equilateral triangle of how many units? 2 units. Huh? Yes. So we have it as that. This, that, and this one here are equal. So each of the given angles is 60 degrees. Huh? So then and it's 2 units. So we drop a perpendicular from one of the vertex down there, which is going to bisect the base. So that we have this one here as 1 unit, this one here as what? 1 unit. Then we determine the height of that given triangle, which is going to be square root of 3. So now then from this one here, now then we can work out. Like for example, cosine of 60 degrees is going to be the same as adjacent over what? Hypotenuse, which is half. What about sine of 60? Sine of 60 degrees is going to be the same as opposite root 3 over what? Root 3 over 2. So now then we can now substitute it in our equation now. The one we had simplified. Huh? So cosine of 60 is a half. Minus negative root 3 over 2 divided by what? Root 3 over what? Over 2. So now then we go ahead. Let us work out the numerator. If you work out the numerator, what are you going to get for the numerator? The numerator you work it out, you are going to get minus, and a minus gives us a positive. So this one here is going to be the same as this. It's going to be 1 plus root 3 over 2. Sawa? Then divided by root 3 over 2. When we work out this, 2 is in the numerator and 2 is also in the denominator as a denominator. So we are going to work it out as 1 plus root 3 over what? Root 3. Sawa? That's what we are going to have. Now this one here is a surd. You cannot leave any given surd with the denominator, so you need to rationalize it. So rationalizing this one here, you multiply by root what? Root 3 over root 3, isn't it? So this one here now simplifies to what? Root 3 plus 3 divided by what? By 3. Which you can now simplify it to what? That root 3 plus what? 1. So this one here, this question is actually testing you about combining the form 2 work, trigonometry, form 3 work, and then again what? Surds. That's how you are supposed to solve it. That's why you have been taught without using mathematical techniques or calculator. I think maybe that should be the last question, yes?
I have a question concerning the calculator can do.
Yeah.
Are you supposed to multiply the side by a negative and put negative root 3?
That is for the denominator. No, there is this one when we are taught to surds are irrational numbers. So we've got irrational numbers and rational. So surds are irrational numbers. So normally when the denominator is a surd, which is an irrational number, you rationalize it. And rationalizing it is making it a rational number. That's it. That's what rationalizing is. So that's why we want to rationalize root 3. So what we do is that we multiply it by what we can use at this as conjugate root of this. What is going to make it positive? So what is going to make it positive? The easiest is, there might be several, but the easiest is you just square it, multiply by that. So you don't need to have the negative. You don't need to have the negative. Because also, mathematically, you cannot leave any denominator as a negative. Like now, for example, if I can give you this, if you leave the answer as this, let's say root 3 over negative 1, that is not simplified. To be simplified, it will be negative what? 3 over 1, which is not still simplified, which should end up giving you negative what? Root 3, negative root 3. Yeah, so that's why we don't need to multiply by a negative. We are only going to be guided. Like, for example, if it was negative root 3 as the denominator, then we would have multiplied by negative root 3, because we want to make it a rational number and preferably what? Positive.
Hello, Mr. Ileri.
Yes, hello.
Muvuti girls, eh?
Yes.
The girls have a question.
Yes.
They're asking, do we have specific topics for paper 1 mathematics and specific topics for paper 2 maths?
Not really. In paper
yes.
one, we usually base that for form 1 and form 2, and then they divide it again to form 3 and Form 4. So they only distribute the given percentage. So in paper 1, they'll test Form 1, Form 2 work between 70 to 80% will be Form 1, Form 2 work. Then between 20 and 30 in paper 1 will be Form 3, Form 4. Then paper 2, they only reverse in paper 2, whereby Form 1, Form 2 work is going to be between 20 and 30, while in Form 3 and Form 4 will be between 70 and 80. So that is what happens, yeah. So they might not say that there are specific ones, but that is the, in paper 1, the bulk of it will be Form 1, Form 2. In paper 2, the bulk of it will be Form 3, Form 4. Hope you answered.
Yeah, very well.
Okay. Welcome. Katoloni?
Hello, Mr. Iledi.
Yes.
Kuna msichana hapa nataka kukuuliza swali. Muvuti Girls, eh?
Again, sawa.
Muvuti Girls.
Yes.
In the scale given in paper 2, let's say section B, how do you apply on the units and the scales numbers that you are given?
Come up again. Come up again.
In drawing the graphs,
Yeah,
the examiner, you are given the scale to use on the units.
Yes. Yeah.
Let's say you are told like 2 units present like 5 centimeters.
Yeah.
Do you just skip 2 boxes or you just leave like how many?
Okay, thanks so much. That question is good. When we are given scale, the examiner will guide you. He'll tell you that in the vertical axis, use this to this. Like, for example, that one comes up mainly like in trigonometry, whereby he'll tell you that on the x-axis, use 1 centimeter to 2 units, or 1 centimeter to 1 unit. And on the vertical axis, that is y, use 2 centimeters to 1 unit. So you are supposed to follow that, what he has given you. The scale given must always be applied. You use that, what he has given you. But then if you have not been given, then you've got the choice of you working out with a scale. But that scale you are going to choose must be 2 conditions. 1, it must be able to accommodate all the values you are going to plot, that is from your table, and it should be what? Even. So when given the scale, you must follow it. And that also applies in all other things. Like, for example, if the examiner tells you, take pi to be this, 22/7, you must use that. Take the radius of the earth to be 6370 kilometers. You must take it as that. So when given the scale, you must follow it. When not given, then choose a scale which is going to be accommodative and even. Answered?
Yes. Another one, eh? Last one.
Ukiambiwa to expand x power 5 na ufike, yani umepewa hiyo range, ufike
Binomial
x power.
expansion.
Yes.
Yeah.
Ukiambiwa u expand up to x power 3, unaweza penaliziwa.
If you have been told that you expand it to x power 3 and then you go ahead, you might not be penalized. But if you are given that you expand it to x power 5, but then you don't get to x power 5, you will be penalized. But if told that expand it to this, if you go beyond, there is no problem. But normally that question in binomial expansion follows something else that you are being told, use your expansion to solve this. So if you had been told to move up to x cubed or x power 3, then when you are using that, you should limit yourself to x power 3. If you go beyond that, then you will be penalized.
Thank you.
Hello, sir. Hello, sir.
Hello?
Hello. Yes, can I ask a question, please?
Yes, welcome.
I was asking,
Yes? Yeah,
when drawing graphs on histogram,
yeah.
are we supposed to break the line or we draw from the origin?
Okay, that's also a good question. In histograms or even in statistics, it depends with the given data. Anytime you are going to break normally the horizontal axis, it depends with the data where it starts from. Like, for example, I can give you some given examples here. Like, let's say these are marks, and then there is frequency. So we've got 10 to, let's say, 14, 15 to 19, 20 to 24. And then we are given the frequency as 3. This one here is 5, and this one here is 2. So if you are going to draw, let's say, for example, accumulative frequency, or gave accumulative frequency, then you will need to have this CF, which is going to be 3, 8, 10. So on the vertical axis, you are supposed to have cumulative frequency. On the horizontal axis, you are supposed to have what? Max. But since it is give, then we must make the data continuous, which means we are going to use the limits. Like, for example, the first class will be from 9.5 to 14.5, then from 14.5 to 19.5, and from 19.5 to 24.5. So it's supposed to be continuous, and this one here is going to be the cumulative frequency. So this will go with 3, this one here will go with 8, this one here will go with 10. But we normally plot the upper limit versus the cumulative frequency versus the upper limit. That's the right way to put it. The cumulative frequency versus the upper limit. So if you check your graph here now, you could, where the two lines meet always, where the x and the y axis should meet, will always be 0. Will always be the origin 0. Then you can now work out this one here, starting from 0, and then you work it out. That, for example, you have 10, 20, 30 like that. And then you plot this, whereby you can have now, we are going to start from 9.5, but we are going to have it with 14.5. So from here, you get where you have your 14.5 from your scale, and then you plot it. You plot this. Let's say this is 5. Just use that, 15, 20. So you plot the 14.5 with 3. You plot the 19.5 with what? The 19.5 with 8. From this one here, then you'll just locate where it is, and then you can plot the 24.5 with 10. That's one way of working out that. But then you check that you find that this graph is shifting from this given, from 0 up to 9.5, there's nothing there. Actually, up to 14.5, there's nothing you've worked out. That you have started from 0. So then now you can choose and work out the same graph, but using it this way now.
It's another question.
Ngoja kwanza. You have it as that. That was our 0. So now instead, you can now, which is even going to be more accurate, you can even now start, you still have the same. You have 5, you have 10. Then here, you can start with 9.5. This is 0. The origin here is 0. Then you can start with 9.5, then 14.5. Then you go to 19.5. And then what? 24.5. But then if you check between 0 and 9.5, that scale is not the same. Because those are 9.5 units, while between 9 and 14.5, they are only 5. So you show that this first part of the graph is not even. So what you do, you work with, you break this one here to show that it is not even. So you break off this one here, and you have it as that. So when one part of the graph is not the same as the other, that is the only part you break, but the axis must meet at 0. Must meet at 0. So I don't know whether you have been answered.
Yes.
Okay.
Another question.
Wait first.
If it's a math at the origin, so the x-axis to be 0. Can you start with the x-axis?
we should always, the origin must be at 0, 0. The origin must be at 0, 0. Because that will be translating the graph. Yeah. Yes, Muvuti. You can now ask.
Yes, in section B,
Yeah.
are we allowed to do with both methods and leave them? If one is we feel that it's wrong.
If you feel one method is wrong, you cancel that and move to another one.
Yes, in section B, is that allowed? You leave both methods.
We have said, or rather, the best thing is that the examiner marks everything you have done. And in section 2, in section 1, you are supposed to do everything. In section 2, not actually section B, but in section 2, you are supposed to have to answer 5 questions. So if you have not answered more than 5 questions, you don't need to cancel anything. Even that one question you need to be marked and you feel that you have done one part and you are not very sure of it, just leave it and continue with the other method, provided that number is going to be marked. You only cancel in mathematics, and get it straight now. You only cancel in mathematics if you have done an extra number. All these other things, leave them there. Let the examiner mark everything. And you can even have said that you can even guide that examiner. You might find that you have already done so many methods, the place is full. In section 2, we have got 8 questions. We are not going to do 3. There is some space in the other 3. Guide the examiner. This number, I've done it in, move to this page, or move to the space in number that. He'll still go and work out there. So only cancel if the extra question in section 2. Answered? Muvuti, answered?
Yes.
Okay.
Hello.
Yes, hello.
Hello.
Yes, I'm hearing you.
Eluvia Secondary School has a question.
Yeah.
Eluvia Secondary School has a question.
Yes.
My question comes from section A. When you work out a question and you find out that you are incorrect, and during the examination time you gain a concept on the question and you work it out, you work it on the space that
On the space that Eluvia might have lost him.
was left aside. Does the examiner mark all the he'll mark everything?
He'll mark everything.
My
We
question
have
comes
said that.
from
Yes. For any question?
when
Are you getting me? Are you hearing me?
yes.
Hello, Eluvia.
Yes, I'm hearing you.
The point is this, if you work out a question, any question, not even in section 1, and it's not section A, it's section 1. Even in section 1, and you work out a question and you feel it's not correct, don't cancel it, because canceling doesn't create any space. Just work out with the space, if there is space in that question, or direct the examiner wherever you're going to have space. Even at the back of those given papers, you'll find some blank space. Move the examiner there, work out there, don't cancel. Don't cancel what you feel is wrong. Let the examiner decide whether it is correct or not correct. So work it out there, or wherever you've got the space, and leave it as that. The examiner will mark. He is supposed to mark everything in that paper. That's why even in mathematics, there's nothing like rough work, that you carry a paper for rough work. No, that rough work is part of working out. Even writing on the margin, that working on the margin, you can even score on the margin where you multiply. Maybe you are looking for the LCM, like the fraction we had. You are looking for the LCM there, so that you transfer as -1/15. Where you had the LCM on the grid, we'll mark there and transfer them.
Okay,
So
thank you,
don't
sir.
cancel.
Okay, thank you.
Okay, welcome.
Another question?
Yes.
Hello. This is from K.C.S.E, yeah?
K.C.S.E secondary, yes.
Yeah, the question is coming from statistics in form 2.
Yes.
You're given a range of values in terms of inequalities. For example, you are supposed to be plotting an histogram. Then you are given a range from of 0 is less or equals to x is less than 5. Then maybe the next range 5 is less or equals to x is less than 15.
Yes.
Can you change you change that statement from the inequality, maybe you write it in terms of from 0 to 4, then from 5 to 14.
No, you shouldn't change that, because we know that when you are drawing an histogram or an ogive, you make the data continuous. So in fact, the examiner has even done some bit for you. He has made already continuous, because between 0 and 5, then the other one starts from 5 to 10 or to 15, and the other one starts from 15 to that. He has already made that data continuous. So you don't need to adjust it if it is a graph you are going to draw. Even on the frequency, if it's already given as a table, they will already have the frequency. So you don't need to change that, because if you're going to draw an histogram or the ogive, then you will use the continuous data. So the examiner will even have assisted you, so you don't have to change. You got it?
Question. Yeah,
Yeah.
we are getting that. As a different question.
Yeah.
In that class form 4, whereby you are solving question. Yeah, whereby you are solving a question either using the trapezoidal rule or the mid-ordinate rule. Yes. Then maybe the question requires you use the mid-ordinate rule. Then by mistake, they misread the question, and then uses the alternative, which is the mid-ordinate rule. So if the working is correct, but the formula is different, this well, mark?
You won't score, because we don't, examination council doesn't allow misread of words. You have misread mid-ordinate as trapezium. Those are words. So you cannot score, because you have done a wrong method. Yeah. There was a question from here, yes? Yeah. You have not used to the calculator, the one which is allowed. You will know, the examiner will know. By the way, the examiners are mathematicians, so they'll be able to know. When you are taught to use logarithms, they expect you to use, actually logarithms is about using values to 4 decimal places. So they expect it to be up to that given level. But you can still use the calculator and then limit yourself to 4 decimal places, and it still work.
Have a question?
Yes.
Hello, Mr. Ileli.
Yes, hello.
I have a question.
Hello, Mr. Ileli. Hello.
Yes.
Yes, we still want to go back to that question on broken lines.
Yeah. Statistics.
The student, yeah, the first one that was asked about broken line on when you are starting a graph.
Yeah.
The student want you to clarify for histogram, not for bar graphs.
Even
she
for
wanted you to.
For histogram, it is not still okay. Yeah. Still, provided you know there is a condition about the scale. The scale must be accommodative and even. So to make it even, you show where it is not even with a broken line. Huh? So provided you have worked out from the base that you work out those given values, and then you give maybe 1 centimeter to 10, like that, 20, that is okay. But the moment it is changed, that 1 centimeter is not equal to that, even if you are drawing an histogram, then you must indicate that part which is not even with a broken what? Broken line. So it happens in all graphs, and not even in statistics, in all graphs, if that part is not even. Answered now?
Hello, Mr. Ileli.
Yes, hello.
Elimoses from Wafam Secondary School.
Yes.
I'm Elimoses from Wafam Secondary School.
Yes, go on.
I have 5 questions.
Okay.
Okay, first question. Is a candidate penalized or given a mark if he or she goes beyond calculating and has found the correct answer?
He has calculated and got the correct? I think you are losing him. Hello? Hello? Hello?
Yes.
Hello, your question is not coming out clearly.
Okay, what I'm asking,
Yes.
if candidate
Yeah.
goes beyond calculating and he or she has found the answer,
And then goes ahead.
he penalized or
No, if I've got your question, is you're asking whether if somebody goes beyond what was expected, whether it's penalized.
Yes.
Hello? Yeah, he isn't penalized. The examiner, there are marks awarded for every given step. So by the time he arrives at the answer, the mark will have matured. The examiner will mark up to that given level and leave the other part. We will not penalize. We are not going to be penalized.
Okay. Another question.
Yes.
If a question has an error,
Yeah.
what action is taken?
If a question has an error, normally the procedure of NEC is that they are supposed to correct it during the exam. If they don't, then at the marking center, the examiners will work out with what was in that question and work practically what the candidate was expected to do and award the marks accordingly. You are not going to be penalized because of a mistake made by the setter. So the chief examiner will organize and work out that question the way it is and award marks. Answered?
Okay. Another question.
Yes.
Is there any particular type of graph?
Any particular type of?
Is there any particular type of graph in a question which comprises of graph?
Particular time, I'm not getting you. Is there a particular time?
Is there any particular type of graph which as a candidate must draw in a question which comprises of a graph?
Not really. You only need to follow the instructions given by the examiner. There is no particular way you have a method. It's only that just follow the instruction. If you have been told to do this, just follow that instruction. If I'm getting your question correctly.
Okay, another question. If a student copies the value in a question in section B, is that question considered as done? If a student copies the values in a question in section B, is that question considered as done?
If he copies the values.
Yes,
I'm not getting
in a question in section B.
Yeah.
If a student copies values in a question in section B, is that question considered as done?
Or if he copies. Anyway,
yes.
It's like this. And it's like this. For any given question in section 2 to be considered to be done, there must be some working from what the expression was done. Like, for example, if maybe it was a question about area, and this area was involving a formula, the moment somebody substitutes that given formula with the values in the question, he has already attempted. Not that he has gone up to the answer, but he has already attempted. So that question is considered as attempted. But then if he just copies what is written by the examiner, that is like copying and pasting, then he has not attempted anything. So that one is not considered as done. Done must have been seen to have somebody to have analyzed the question.
Good afternoon, sir. Good afternoon.
Good afternoon.
I have a question that what if you use some method that you are not Good afternoon. Good afternoon.
Good afternoon.
Yeah, the question is that what if you use a method that was not taught in class or is not in the syllabus, but you apply in a maths, is it markable or you will be penalized?
That is a very good question. If you apply method of fourth-year university, provided it is mathematical, it is going to be marked. If it is mathematics, you cannot penalize for somebody, you cannot penalize a person who knows more. Reading ahead. Reading ahead is not a crime. So it's going to be marked, provided it is mathematical.
Thank you.
Welcome.
I have a question, sir.
Yes.
Have a question. What criteria do you use when coming up with the grading system in mathematics during KCSE?
What happens is that as examiners, you recommend from the performance of the students, you recommend how the marks are being done. Like you work out, you usually give out what is referred to as the awards, and then you consider a pass, which is a D+. You feel that for somebody to get a D+, you'd score this mark. For somebody to get a credit, which is B-, he should get these marks. And for somebody to get a distinction, which is A-, should get this mark. But then finally, the person who makes the final decision is the examination council. You only give out recommendations and the examination council does the rest. So you only tell them that from this year, this is what the performance was. So we wish that these marks would be given at this level, but the final word is with the NEC.
Good afternoon, sir.
Afternoon.
Yeah, I have a question on SAT.
Yes.
A question on. So if you are being given 1 minus sin 30, all of 1 plus
1 minus sin 30,
all over 1 plus all over cos 40.
Cos 40.
Yeah.
1 plus cos 40.
Yes.
Yeah.
Using SAT. Solving using SAT.
Then it is, you only need to substitute those values to be as SATs using the form 2 knowledge of angles, that is that is trigonometrical ratios of special angles, but I don't think 40 is one of them. Maybe this would have been different, maybe cosine of 60 or something else. Otherwise, cosine of 40 cannot be a SAT. So you only substitute those values using that given knowledge of form 2, and then you go ahead and solve it as a SAT.
Okay, thank you.
Good afternoon.
Afternoon.
This is Hapa Kitanga. We have a question on rotation and rotation, especially section B.
Yeah.
Where a student is supposed to rotate a question, a figure.
Yeah.
And after rotating, is supposed to enlarge, maybe.
Yes.
If a student is supposed to rotate on a maybe positive 60, the instructions are saying the student to rotate on positive 60, and he or she rotates on negative 60 instead. Yeah. And the consecutive questions that are following below, they are depending on the rotations or the enlargement, the one that he has done. Is he or she going to be awarded the marks or not?
In this case, he won't be awarded because in those given consecutive, the object, the second image is as a result of the first image. So if the first image is wrong, then automatically the second image is going to be wrong. So if he messes up in the first one, then he's going to miss everything because that was the wrong mathematical concept. Because if you have been told to rotate positive 60 and then you do negative 60, then it means you don't have the concept in mathematics about the rotation and angle of rotation and direction. So that's the wrong method. So you will lose even for the others because they not be the right figures.
Okay, thank you.
Yeah. Yeah. Transform.
Does it mean that you have to cram the matrix because you are not, if you are in it is in section B, you can rotate it. Yeah. But now you have to find the matrix on the image. And let's say, for example, I have to find the matrix which are given
the image and the object.
Yes. How do you do it?
It is like this. One concept you should understand is that not all transformations can be represented as a matrix. That's one thing you should know. That not all transformations can have a transformation matrix. Those transformations which have got a matrix for transformation are those given transformations which are going to leave the origin invariant. So if it is a reflection, then the mirror line must go through the origin. If it is a rotation, then the center must be the origin. If it's an enlargement, the center must be the origin. Okay, to come to your question now, is that if there is already, you have already been told by the examiner to find the matrix of transformation, then it means that transformation can be given out as a matrix. So you only need to use, there is a famous word, MOI. So the M is for the matrix of transformation, O is the object, and I is the image. So if you have to look for the matrix, you just let the matrix be what? A, B, C, what? D. And then you have now the object given as a matrix to give you now what? The image given as a matrix. And then you multiply what is on the left-hand side. You are going to have some given values there. So you come up with 4 simultaneous equations. 2 involving A and B, and others 2 involving what? C and D equated. And then you solve that. And then you finally combine your A, your B, your C, and D as a matrix. Yeah. But there's also another way of finding a matrix. If you are using you can use the unit in most of the given in most of the given transformation. You use the unit square, whereby you work with I, which is coordinate 1, 0, and you use J, which is coordinate what? 0, 1. So you use the identity matrix, which is supposed to be 1, 0, 0, 1, whereby 1, 0 is for I, and 0, 1 is for what? For J. So if, for example, is a rotation of 90 degrees and clockwise, then you just check where I goes. It is 90 degrees and clockwise. So we are going to move that direction, 90 degrees. Kwa hivyo I itatoka hapa, ikuja hapa kuna J, si ndio? So the transformation matrix now becomes the image of I and the image of J. Kwa hivyo I inaenda kwa 0, 1, na J inaenda wapi? Kwa negative 1, 0. So negative 1, 0. So actually that is the matrix for positive 90 degrees turn about 0, 0. If it was maybe half turn, again you use the same half turn, I will go to negative 1, 0, negative 1, 0, and J will go to 0, negative 1. So that is the matrix for half turn. So you can work out with that. But bearing in mind that not all transformation can be represented with what? A matrix. Yeah. Yes?
Good afternoon, sir. Good afternoon, sir.
Good afternoon.
When you're given a table of, for example, log P and log X, how are you supposed to plot it against along the X-axis and the Y-axis?
Then it will depend. It will depend with the information given, because there must be a relationship between P and X as a statement. Like, for example, you will be given maybe P is the same as X, Kx power n. So for you to be given this one here, then you are being told maybe P is a variable and X is a variable. So it will depend with what is given as the equation. For example, if you have been given P is equal to Kx power n, then you will work out here, say that log P is going to be the same as log K plus n log what? X. So if they have given you now log P and log X, then you just go to the linear equation, which is Y is the same as mx plus c. So we know when we plot this Y against X, then the gradient is going to be m, and the Y-intercept is going to be what? C. So from our expression here, log P will be on the vertical axis and log X will be on the horizontal axis. And out of your graph, then when it comes out as this, when you plot that, then it will look like this. It will look like that is log P, and this is log X. Let's say we have it at that. So this point here, N, this intercept here will be log K. The vertical axis intercept, while the gradient of this one here will be N. So it will depend with the initial equation which you are working out. Answered?
Not yet. My question is, when you're given log P against log X, where will you plot the log P and where will you plot the log Q?
I thought that's what I was telling you. In the first place, it will not just be given log P and log X just without an equation up there. So it will depend, because you can either have log P on the vertical axis or on the horizontal axis. So it will depend with the statement. So for you to work out this, you must reduce that given equation as a linear equation. Y is equal to mx plus c, such that whatever you're going to plot on the vertical axis, again, is what you're going to plot on the horizontal axis. Then the coefficient of the variable on the horizontal axis is going to be the gradient, while the constant without the log P and the log X is going to be the intercept of the vertical value, whatever you have plotted on the vertical value. So it will depend with the equation. Have I answered you now?
Yes, thank you.
There was a question from here, yes?
Good afternoon, sir.
If you work with pencil, if it is readable, it is going to be marked. But I encourage students not to use pencil, because you do the exam here and it's moved to Nairobi. In that movement, the pencil is not very permanent. It can disappear. So work out with work. In other words, it can get erased, isn't it? That's what I mean by disappearing. So write with a pen. Write with a pen. Unless it is a diagram you are drawing, write with a pen. It will still be marked, provided it can be read. The examiners are not that mean. They are human beings.
Good afternoon.
Yes, afternoon.
Yes, I have a question concerning, is it a must to indicate the units of a measurement? Like, for example, when we are calculating area of a certain figure, you give 40 instead of 40 centimeters squared. Will you be penalized?
It's okay, thanks. In mathematics, we don't mark units. Because if you have been told to calculate, find the length of this in centimeters, whatever you have started working is towards getting that length in centimeters. So you don't need to indicate there the centimeters. You don't need to have the units. Even sometimes if it is 40 and you write 40 people, the examiner will ignore the people, because what he was looking for is the 40. So the units are not marked in mathematics. But the only workout is, for example, I'll give a very simple example. If you are supposed to get the area of a triangle, which is half BH, and then the base is given in centimeters and the height is given in meters, then here the units come in handy. That if you are going to get whatever the area, either in centimeters or in meters squared, then the units must tally. That if you are going to get in centimeters, then you must change the height into centimeters and then multiply. Or if you are going to get them in meters squared, then you must change the base into meters and then multiply. Otherwise, in mathematics, units are not marked. They are ignored. Answered? Yes? Yeah. in a square-based pyramid. And I don't know why you have talked about a square-based pyramid. What about if it is rectangular-based? In 3D, the unforeseen line should be broken. Let me correct it. But this is continuous. This will be like that. This one here is also supposed to be continuous. So this should. So in this one here, in any given pyramid, there are two concepts we should talk about. There is one where students confuse. There is what we refer to as a right pyramid. A right pyramid. A right pyramid means that all the slant edges are equal. Like now, for example, in this one here I've drawn here, this pyramid with the base A, B, C, D, and then there's the vertex V. If it is right pyramid, then VA is equal to VB, which is equal to VC, which is equal to what? VD. And when it is a right pyramid, then V, the vertex up there, is vertically above the center of the base. Vertically above the center of the base. So VA, they are referred, VA, VB, VC, and VD are referred to as the slant edge. Slant edge. Because all those are edges, they are the slant edge. But then within the slant edge, it forms a plane. Like for example, plane VAB, that phase, or plane VBC. So in this one here, we've got what we refer to as the slant height. Let's say that is M. So in this case here, VM will be the slant height. Slant height of the base VBC. So that will be the slant height. But then the height of the pyramid will be, we have said that the V will be vertically above O. So when you join V with O, whereby O is the center of the base, then VO will be the height of the pyramid. So there's the slant edge and then there's the slant height. The slant height is simply the height of the faces of the pyramid. But in a cone, it happens that the slant height is also the slant edge because it is a curve. Yeah, which is actually normally we label it as what? L. We label it as L. So the slant height is the height of the face of the pyramid. Yeah. The base, actually it's supposed to be that area of the base times what? Height. This height is the height of the pyramid, which is the VO. So it's going to be the area of ABCD, then multiplied by VO. Have I answered you? Yeah, because you use the height of the pyramid. The height of the pyramid is actually height of the pyramid is the perpendicular distance between the vertex and the base. Yeah, the vertex and the base. So VO is going to be the height of the pyramid.
Hello. Hello. Hello, Mr. Ileli.
Yes, hello.
What is the concept behind drawing solid nets? Drawing and sketching solid nets.
Okay. Drawing, when it comes up in two, you can be told to draw, you are given a solid, then you are told to draw the net. Sometimes the examiner might use the word sketch, but the word sketch is not appropriate. When you have been told to sketch, in other words, if you have been given the solid, it means they want you to draw a net which is going to form that solid. If folded, it's going to form the solid. So the net must have the same measurements as that of the solid, because the net is what is supposed to be folded to form the solid given. But when you are drawing the solid, the given when you have been given the net and then you are supposed to construct a solid or part of that given solid and then you are supposed to construct it, then the lines which cannot be seen as the hidden lines, the ones we refer to as the hidden lines, should be broken. But they should be the measurements like what is in the solid or in the net. In simple words, the net, if folded, should form the solid. Or the solid, when opened up, should form the net. That is, the measurement should be the same for the solid and the net. Answered?
Yes.
Okay.
Another question.
Yes.
When dealing with whole numbers in board mass, what is the are we supposed to leave the answers in decimal points or in fractions?
Normally, if you are dealing with fractions, the most normal thing to do is you work it out as fractions. You give the answer as fractions. If they were in decimals, you can give out the decimals. But the examiner is not penalize you. But normally, normal logic is that if you are working with a fraction, before you get to the decimal, you will have worked a fraction. So at the level of the fraction, the examiner will give you the mark. And if you give it out as a decimal, you'll have already scored. So there's no problem. But normally what the examiner has done, you just work it out the way he's done it. But there's one thing you should remember about fractions. Fractions, when you are working out with a fraction, then it must be in the simplest form. And it must be either a mixed number or a proper fraction, but not an improper fraction as the final answer. Answered?
Yes.
Okay.
Thank you.
There was a question from the back here, yes? Yeah. Yeah. I didn't get that part of the. If you have been given the volume, it will just go with that A8. Eh? Yeah. So provided you know there is the area of the base, the height is the perpendicular height, then you just equate the two. Yeah. Yes. A log X, yes. And I answered him because you know when it is going, if it is going to the x-axis or the y-axis, it depends with the linear equation. Because in the linear equation, y is equal to mx. Y is equal to mx plus c. Then it will depend with this. Like for example, if we have p is the same as mx plus c, or log p is the same as m log x plus c. If you are going to draw a straight line graph, then it should be log p against what? Log x. Yeah, yeah, and that's why I was limiting it. It depends with the linear equation. Eh? Yeah, because if we also change this one here, like for example, if I change this one here to log x is the same as m log p plus a constant c. Then this time I'm going to have log x being on the vertical axis and log p being on the horizontal axis. So it depends with the linear equation there, y is equal to mx plus c. But the concept is the same. Whatever goes with the vertical axis and the horizontal axis, the gradient will be the coefficient of the variable on the horizontal axis. Yes? Yeah? 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 You are given the center of enlargement, the scale factor, the coordinates of the object. It simply goes like this. Eh? It simply goes like this. In transformations, if for example we have this is the center of enlargement, this is the center, There's a, let me use this one here as C. Let me use this one here as C. That this is the center of enlargement, this is the object, and then this is the image. So the relationship between these two is that from the center of enlargement to the image divided by from the center of enlargement to the object gives you the linear scale factor, which is also the same as the enlargement scale factor. So this one here goes to from the center of enlargement is going to be the center of enlargement to the image is always going to be the same as the linear scale factor, which let me use it as K, then multiplied by from the center of enlargement to the object. So if you have been given the coordinates, then you will only need to form an equation relating to these ones here, either using the X or the Y and equating them. That the connection is from the center of enlargement to the image is going to be the same as the scale factor multiplied by from the center of enlargement to the object. That's how it goes. So you just form that given expression, whether K is negative or is positive. Yeah.
Hello. Hello, sir.
Hello. Yes. Hello.
Hello, sir.
Yes, I'm hearing.
I have a question.
Yes.
And the question is in area and approximation using trapezoidal rule or mid-ordinate rule, are you supposed to give your answer in a fraction or a decimal?
It will depend with the values given out by the examiner. If it is given as fractions, then you can still give out the answer as fractions. If it is given out as decimals, you can still give out those. But there's no big deal when you give it out as a fraction and you give it out as a decimal, if it is the right thing. Because all of those, actually, they are fractions. One is a fraction with a numerator and a denominator, while the other one is a decimal fraction. So all of them are still the same concept.
Thank you. Another question.
I'm sorry, now we might
Another
not.
question.
Maybe the last one. Huh? Yeah, maybe the last one.
Yes.
Yeah.
My question is, you have been given a graph, you draw a line.
Yeah.
And the time elapsed during the examination time. While you haven't drawn the line, can you use a freehand drawing the line?
No, you will get a 0. You will not score because a line must be drawn with a ruler. Anyway, I'm sorry, maybe the questions are many and the time is not really enough for us to answer all the questions, but I understand this is because it's the first time we are having this. So since we've got another session in the afternoon, I'm going to ask all the participants to bear with us with the situation and that we might be able to work on maybe some other time. Otherwise, thanks so much for your contribution and for working all of us together. The only thing is that we are based at, or rather we are aimed at